All right, this lesson might get a little bit tricky, but we just need to try and follow along the best we can. So we have Prim's algorithm for these minimum spanning trees. So our minimum spanning tree is a spanning tree of minimum length. We're trying to find like that shortest distance. It connects all the vertices together with the minimum total weighting for the edges. So to do this, we choose any vertex in the network, choose the edge with the least weight connecting this vertex to another vertex, look at all edges connecting with these two vertices and select the next edge with the least weight to add to the tree. Look at the vertices in your tree and choose the next edge with the least weight to add. Make sure you don't have any cycles, we don't want to go around back to where we were. And repeat step 4 until all vertices are connected. Okay, so looking at this diagram here, we need to use Prim's algorithm to find a minimum spanning tree. So it says choose a vertice. It's up to you where you start. I'm going to start here at A, as I think it might just make it a little bit easier for us. So from A, we're looking for then the shortest edge. So if I go A to C, I have 5. And I think it's easier if you write this down to make sure you don't lose track of where you are. So we go A to C. Instead of drawing all over your diagram and then having to rub things out, write it down. And then from here, the shortest the shortest edge is to D. So C to D, which is 5. Now I need to again find the shortest one from here. So I'm going to then go to F. That's my shortest vertice. But if I'm looking at this, I need to think, well, I can't make a cycle and I still need to get to B. So I need to think, well, I can't do that because I would then need to come back to B, back to D, which creates a cycle. So that one doesn't work. So I'm going to have to go D to B. So D to B, which is 9. Then I can go to F. So B to F, which is 3. From here, the shortest one is going to be to G. So F to G, which is 4. Then I'm going to go G to E, which is 7. And then I need to, from here, I've gotten to E. I don't need to go back to D because I've already been to D. So my total there is going to be 33. Now we need to check where we're going from there. So we need to maybe go and try some other ways to get through. So if I'm starting again, I'm going to go A to C, which is 5. I could go C to B, because if I look at this, this is 11, but the way I went before, this made 14, so it was a bit bigger. So we go B to C, which is 11. I can go B to F, sorry, that should be C to B. C to B, B to F, which is 3. I can still go then F to G, which is 4, G to E, which is 7, and then E to D, which is 10. That gives me 40. So we know that one's out because it's already bigger than that first one. If you wanted to start somewhere else, we've exhausted a bit of the paths from here. We might be able to start at D in the center. So if we go D to E, which is 10, not the shortest one, but we'll just try this way. E to G, which is 7. Then we're going G to F, which is 4. F to B, which is 3. B to A, which is 8. And A to C, which is 5. That then gives us 37. So it's less than this second one we did, but it's still more than this first one. And again, you might choose somewhere else to start. It's about just going through, depending on the time you've got in the assessment, but it's trying to find that shortest path. And it might be the first one you do. But if you do a couple more to check, even if you maybe don't get the exact shortest one, so long as you've shown your marker that you have attempted and trialed a few different ones, you should be able to get some marks in those questions.